Okay, hello and welcome everyone. Thank you for joining us for today's webinar hosted by the LIMS Forum. My name is Dinah Ramirez and I'm your moderator for today's webinar. Today's webinar, a guide for laboratory systems management, is part 5 of a webinar series that's been presented by Joe Laskowski. Today we'll be focusing on supporting laboratory systems. If you're joining us for the very first time in this webinar series, Joe is an experienced laboratory automation computing professional with over 40 years experience in the field, including the design and development of automation systems, LIMS, robotics, and data interchange standards, and consults on the use of computing in lab work. He currently works with companies to establish planning programs for lab systems, develop effective support groups, and helps people with the application of automation and information technologies in research and quality control environments. We're very excited to have Joe with us here again for part 5 in his series. So let's go ahead and check in with Joe and we'll go ahead and get started. All right, Joe, thanks for joining us today. The floor is yours.
Thank you, and welcome to the 5th session in this series. We'll be looking at the support requirements for laboratory informatics. That includes the roles of lab personnel, IT support, and vendor relationships. As we've noted in these webinars, this companion book will provide useful background information on the technologies, support, and other factors that can impact your ability to effectively use these systems. It should prove to be a useful reference as the webinars get into more technical details. Much of the material in this session is expanded on in Chapter 2 of the book. The previous sessions have introduced the major systems in laboratory informatics and looked at how the return on investment can be measured and evaluated. In the last session, Webinar 4, we extended the considerations for choosing between LIMS, ELN, and SDMS for a single lab, and the potential for using the same technology in multiple labs in a variety of configurations, including SAS and remote servers. During that session, we began to see the need and potential roles for information technology support. This session is going to cover that topic in more detail. Once upon a time, when people first began to drive cars and trucks, they had to be able to drive them and navigate their way around. They also had to be able to repair them if something went wrong. There weren't any road services, even if you had a means of calling them. Eventually, people recognized the commercial benefits of automobile repair, and service stations developed. Over time, cars changed to become more attractive to a wider range of people, easier to drive with more features that drivers and passengers wanted. Along with that, automotive services grew and met the need to support the increasing mechanical sophistication of the cars that were produced. Today, service groups have to deal with the basics of automotive maintenance, but also have to be able to deal with specialized systems, many requiring additional specialized education. In the early days of laboratory computing and experimental work, it was very rare to find a turnkey computer that supported an experimental setup. The scientist, in addition to doing science, was the systems designer, the manager, and the programmer. Just like the early automobile drivers, the scientist had to run the equipment and be his own support. For most labs using computers, the systems consisted of a computer, the experimental equipment, and either homegrown or third-party software that scientists had to configure or modify to meet their needs. Any equipment used in the experiment would be supported by the vendor, but their support was limited to what they provided and not how it worked with other components. The overall success of the system depended on the user, the scientist. Just like automobile manufacturers in the early days of driving, instrument vendors realized that if they want people to buy their instruments, they had to make them attractive, and that meant easier to use and support, with improved productivity gains through the use of computer systems. And just like the automobile repair shops who were faced with systems that require added training, or simply beyond their capabilities, laboratory users found their IT staff often didn't have the backgrounds needed to meet their support needs. They could handle basic maintenance, but didn't have the education to diagnose overall systems issues. The instrument system vendor would support their equipment, but when an experiment moved into coordination of multiple components, the users had to do a lot of the troubleshooting themselves. When we combine instruments, science, and computer systems, there are several areas where it would be difficult to diagnose problems and figure out what needs attention. The issue becomes even cloudier when the problems are viewed as something just doesn't seem right. As we move towards automated procedures that might feed into a centralized database, things become even more complex. We're outrunning basic system support. We looked at this slide in the last webinar. The point was to contrast the typical corporate IT expectations with the needs of laboratory work. One is more structured, the other has more diverse needs, and has their computers connecting to equipment that is beyond the experience of most IT people. We're looking at two different groups, both consisting of educated professionals that have different sets of experiences, needs, and expectations. If those elements aren't discussed and rationalized, we have conflicting points of view based to an extent on a lack of appreciation for those differing requirements. The lab is looking to get their work done using whatever tools are needed, and those tools are diverse, depending on a range of scientific and computing technologies. IT groups are looking at the stability of a large number of systems and a complex networked infrastructure. When many of us first began considering scientific computing in support of laboratory work, we focused on the top 4 bullets on the right. As lab data and information began to become available in digital formats, we saw the integration of those elements into the corporate information pool. In some cases, it was the use of quality control results to provide more timely input into production and solving product quality issues. Researchers began to take advantage of it in large-scale modeling and statistical applications, and we saw the arrival of big data applications. All of this put more importance on streamlining lab processes and moving data and information into places where people could take advantage of it. Laboratory and senior management need to come to grips with the idea that laboratory systems are not just a collection of isolated, independent components. To be done well, they need as much planning and support as any manufacturing production line. Would your company allow us production to be implemented as a series of independent steps, or would they rather have a smoothly function integrated operation? To do that, we need people that can carry out the items noted on the screen. The lab's dependence upon manual methods are giving way to facilities that carry out their work smoothly, with high productivity levels and a return on investment. That usually means automation, implemented where appropriate, with the staff equal with support staff equal to the job. What we need are people that are educated specifically for laboratory technology management and planning. This is more than just an IT function, as it embraces the full gamut of laboratory systems, their interactions and interdependencies. These people would have to work with IT groups cooperatively and be responsible for resolving conflicts and policies. During the rest of this session, we're going to look at the points noted on the screen. The basic premise is one that has been noted earlier in this series. Our ability to effectively use laboratory systems is going to depend upon having qualified people to plan and implement them. We have to put the idea of implementing lab technologies on a case-by-case basis behind us and look at lab operations as a whole. How are we going to meet the lab's needs? You may want to start with manual methods of carrying out lab procedures, but will a growing need for more testing and experimental work cause you to look for forms of automation to keep up with the demand and have you look for more integrated approaches? The items on the screen represent the major groupings of responsibilities that we're going to be looking at. The purpose of these professionals is to bridge the gap in subject matter expertise between lab and IT personnel. From an IT perspective, it could be viewed as a specialization within their organization. From the lab side, it would represent a source of expertise that would help them plan and implement systems they need in their work. These professionals are going to need excellent interpersonal skills. They will need to be able to listen to people's issues without prejudging them, provide clear communications, and be able to resolve conflicts as they occur. Doing that will require that they have access to senior management to deal with conflicts on policy issues. They can recommend solutions, but it isn't likely that they'll have the authority to enact them. This is a place for people with expertise in change management. Their existence in a group foreshadows change and will raise anxiety levels, so clear communications and the ability to put people at ease will be important. Of the items on the previous slide, this is one set of capabilities that's difficult to teach. People can take courses in team building, conflict management, and so on, but realistically, success in these skills is going to depend on maturity, experience, and personality. This map is deceptively simple. The material under Lab Bench and Departmental Technologies includes what we've been talking about in the previous 4 sessions and those that will follow. The items I want to stress here are the software and hardware issues, and there's one point that needs to be made. Laboratory automation engineers are not a replacement for corporate IT departments. In fact, they may be a specialized element of those groups depending upon how the company organizes itself. Their role with regard to computing and networking hardware and software is to support IT policies unless they conflict with lab operations. In those cases, they're responsible for identifying conflicts and recommending resolutions. Among those conflicts are cases where an operating system upgrade might prevent an application software from working properly or at all. The application's vendor may not have completed software certification, testing, or modifications to be supportable under a new operating system version, and the upgrade would prevent people in the lab from getting their work done. They would have a responsibility to evaluate the vendor's ability to keep up with operating system and software development as part of the product selection process. The ideas behind product upgrades, retirement, replacement need a bit more discussion to help flesh out a laboratory automation engineer's responsibility. This is a diagram that I find more useful from the user's point of view. For more details on the entire diagram, please check the reference noted on the slide. Among the phases that products undergo in their development, the most critical for this discussion are when products and technology reach a level of maturity shown by the high, medium, and low impact points. If the product is viable, a new version will be created with added features and capabilities to make it more attractive and competitive. A decision may also be made to completely redesign the product if the underlying technology is dated or to take advantage of new options. The decision to terminate the product could be made if it's no longer marketable. Due to the rapid changing in technology, product lifecycle phases are occurring at an increasing pace. You may pass through several product life cycles and product changeovers during the useful lifespan of the data in your laboratory, which could be decades in biotech and pharmaceutical industries. So how many product versions will your lab cycle through? The possibilities of product termination or significant upgrade are a concern in technology management. Well-planned, well-designed systems can tolerate change. Inadequate planning can put you up against a wall. The same issues can occur when entirely new product or technology is introduced, replacing products that are already in service in your laboratory. Planning against a vendor's product life cycle is a matter of balancing the benefits of new product technologies against the potential for painting yourself into a corner. The choices you or your predecessors can make can limit your future options. These are some of the issues that a lab automation engineer needs to keep in mind so that your lab isn't blindsided by changes in vendors' development programs. Your laboratory is going to be spending a lot of resources implementing systems to make it work effectively. If products they depend upon are slated for retirement or significant upgrade, those systems may either continue using out-of-date components that a vendor may no longer support, or have to spend more resources modifying processes to accommodate replacement parts. The more warning you have about changes, the better you'll be able to handle them. That lead time may give you the time you need to lobby the vendor to ensure compatibility with older systems. These considerations are nothing new. They're points that should have been addressed during the vendor audit phase of the validation process. This received a lot of attention 20 years ago, but I don't know how seriously people are taking it now. The bottom line is simply this. You're going to be spending a lot of resources on developing systems to support your lab operations. If there are critical components, you need to ensure that they are from reliable vendors with a track record of supporting their products and working with their customers. You might look at this topic and say, well, we've been through product changeovers before. And that's true, but in the past, a lot of these changes have occurred when people were using the equipment and could adapt to change themselves. When you're looking at automated equipment, it's a different story. Adaptation may mean reprogramming the entire system. Outsourcing is often used to expand the lab's capabilities for both specialized testing that's needed on an occasional basis or to handle overflow work. A lab automation engineer's role in outsourcing is to help ensure that the results of the work can be used within the laboratory systems. What form, for example, will the returned results take? Are those results in that format compatible with your laboratory systems? Can it be automatically entered, or does it have to be reformatted to work well? Do they have good control over their systems, including backup and archiving? Again, it's a matter of qualifying your vendors, and it's something that an LAE would be expected to help with. We looked at these issues in previous sessions. The LAE's role is to cover a lot of the responsibilities that were directed to corporate IT support. The lab automation engineer's knowledge of lab operations would help ensure that the lab's critical requirements are given the consideration that's needed. I've been referring to the professionals that would be doing laboratory technology management and planning as laboratory automation engineers. The title fits the work. They were working as engineers that will help design, implement, manage, and support laboratory systems that fulfill an automation function. The automation aspect results from the optimization of laboratory processes through a variety of technologies that include instrumentation, robotics, and data systems. So, who might they report to, and where do you find them? The relationship between lab automation engineers and corporate IT groups are a lot like that of professional kitchen designers and installers and people who build homes. The construction crews are there to create the structure, divide it into spaces, and provide the needed infrastructure. When it comes to the space designated as a kitchen, what you have is an empty space with some parts of use-specific infrastructure elements: plumbing, power, floors, walls, and a ceiling. The role of the kitchen designer and installer is to customize that space so it can function as a working kitchen. If there are structural problems, the general contractor resolves them. The role of the lab automation engineer is to build on top of corporate informatics infrastructures and adapt it to the needs of laboratory work. In large organizations, the lab automation engineer may be part of a team. In smaller ones, they may be the team. From a technology standpoint, the lab automation engineer needs to understand science, laboratory, technologies, and the computing infrastructure components. They need to be strongest in laboratory technologies in their application to lab work, good in the sciences, and competent in computing and informatics. The depth of knowledge in the last point will depend on the organization they support and the availability of in-house IT groups. Much of what we've talked about so far in this webinar series, including database systems, networking, and hosting, is common to computer science. A science background is useful in these discussions to understand the differences between lab systems requirements and similar applications in other fields. However, the need for a science background will become evident in the next webinar as we move into supporting laboratory experiments. The best source of these people are those with formal education and experience in science. They would be able to relate to the applications of the technologies and appreciate the subtleties of the work. It would be easier to educate a scientist in computing and informatics than taking an IT person and bring them up to speed on the scientific applications of computing. There is also an interpersonal dimension to this. Scientists will be more comfortable talking with someone who's been in scientific work, and communications is a very important aspect of this work. The placement of a lab automation engineer within an organizational structure will vary depending upon the size of the organization. Their work is neither wholly scientific nor is it wholly information technology. They bridge both endeavors and may prove to be an annoyance in highly structured organizational charts, creating the famous dotted line relationships. In startup organizations, the available resources may be focused almost entirely on getting lab work done. They have funding to prove themselves and demonstrate their viability as a business entity. As a result, the bulk of their resources will be spent on the lab. As we've discussed, the informatics part of lab work needs considerable attention, and because of the need to prove themselves, anything that doesn't contribute directly to their success is questionable overhead. An LAE could be a significant contributor to their work, and it would be reasonable to have an LAE be the IT department. Vendor-supported SaaS informatics would relieve a lot of the traditional IT burden and allow them to concentrate on systems that support lab work. Office systems and infrastructure at this stage would require little active support as long as the equipment, both hardware and software, came from reliable vendors and was familiar to those working there. If the organization chooses to outsource its IT support, they should be able to evaluate the organization's ability to meet the criteria noted in the previous slides. In large scientific organizations, the lab automation engineer would be part of the corporate IT organization and take a good part of that budget. The rest of the IT operation would support administrative operations, as well as non-lab research, including any big data applications. Having a lab automation engineer as part of the corporate IT group would keep them in closer contact to avoid problems developing over policy issues and data and information integration with database systems that are outside the laboratory. The lab automation engineer's primary efforts would be to support the labs. In this structure, the laboratory and scientific work should be the dominant force in the organization, and it isn't likely that the lab automation engineer's efforts would be diverted, perhaps shifted to other projects because of deadline pressures. Other organizational structures may not behave in the same way. You gotta love corporate politics. In manufacturing production organizations, the LAE would be at best part of the corporate IT organization, and even there possibly as a part-time effort or completely outsourced. In this situation, the lab's management is going to have to make sure any user requirements that are developed have strong positions and justifications for its needs to help ensure that the needed systems are put in place when they're needed and with the necessary functionality. There are two issues that can impact the resources devoted to lab work. First, there's a changing nature of lab operations. Expenditures on lab operations are being looked at from a cost standpoint, so the ROI has to be evaluated. As part of that, testing may have been manually performed and then moved to inline testing, changing the nature of laboratory work. Second, as noted in the last webinar, organizations will install enterprise resource planning systems to integrate the computing and data needs of different parts of an organization under one software platform. And with that, life can get very interesting. Companies will often use ERP systems to manage their business operations out of one product platform. That provides a higher level of efficiency and integration. These systems are expensive and have a learning curve that takes time and resources to manage. The IT group may have justified the purchase with the idea that this will be the basis of all the company's database needs. And then the lab comes along and raises its hand and says, we need a database system. IT's response may be, we can create one using the ERP system as a base. So do you build, buy, or rent a solution? Using an ERP system as a base may seem attractive, as some facets of lab operations, particularly LIMS, are similar to other business practices. One aspect of lab informatics that separates itself from business practices is the need for connections to instrument data systems. Before you get into these discussions, you should have a solid set of user requirements documents with critical functionality identified and justified to provide a basis of discussion. In most cases, this is a deal breaker for ERP integration. Once that's realized, the do you really need that discussion begins, and that's up to you to justify. The next step in logic may be, well, we'll do all the non-instrument data system work first and then get to that last. The problem with that argument is that the instrument data system requirements may significantly impact the design of the overall system. And if not addressed early in the process, any changes needed to accommodate that functionality would completely blow the schedule and budget. Corporate pressure for other projects may leave it in a software development limbo. For most companies, buy or rent is the better choice, and by rent I'm referring to the SaaS model, software as a service. The details for this choice are on the screen. What it basically comes down to is that you have access to a proven product with support and a user community to work with to get needed functionality incorporated into the product and help solve common problems. It also means you can get up and running faster than you could with a build choice. How fast can you put the software into practice depends entirely on the preparation you've done in understanding the technology, how it relates to your lab's work, the development of user requirements, and keeping your lab appraised of available products. If you haven't done any of that, you're looking at potentially a year or two's effort. If that work has been done, you should be able to get up and running quickly, particularly if the vendor has a software as a service option that can be moved later on into an on-premise system if that becomes desirable. The biggest issue you're likely to face is the choice between configured and customizable systems as shown on the left. If you can, configured systems are the best option. You don't want to find yourself in a situation where you spent a lot of resources developing software only to have to do it all over again when the next release of that software becomes available. Considering the amount of effort that's gone into these systems, it isn't likely that you'll come up with a need that requires custom software development. If you do find a unique need, contact the user community to see if others are having similar issues, and perhaps as a group, pressure the vendor to make the changes. Large organizations with a number of laboratories may be able to justify the development of software to meet central database systems, a LIMS or ELN, for example. Spreading the cost over a number of labs may be something they can justify, but there are some issues. Can the labs come to an agreement on the basic set of requirements, or at least a foundation that individual labs can build upon? The more labs you get into the mix, the lower the likelihood of that being successful, particularly if they aren't well versed in the technologies. The end result, if a project is successful, is having a vendor that has only one corporate customer with multiple installations that need support. That support will be needed forever, as will the requests for bug fixes and improvements. IT will have to develop its own support staff and be able to train them. There won't be any outside source of expertise. No one else is going to have access to your software. While this organization is going to be running its projects, so will commercial vendors, but they will be adding new functionality to their existing systems. Is the IT group up to the work required? And do they have the level of demonstrated expertise and capability for large projects? What's the likelihood of the team being kept in place and not having people siphoned off for other projects? And finally, What are you going to work with while the development project is underway? How will the accumulated data and information be integrated into the final system? During the session, we've covered a lot of ground around lab system support issue. One point that was noted earlier in this session is that much of what has been covered doesn't require much education beyond a high level of competence in computer systems and an understanding of modern database technology to support lab operations. This is going to change significantly in the next webinar as we move towards the generation of laboratory data and information through instrument data systems and sample preparation. There, the full weight of scientific work is going to be helped, and that session is scheduled right now for May 24th. Are there any questions?
Okay, thank you, Joe. I don't see any questions at this point in time, but if anyone does have any questions, feel free to go ahead and submit those in the chat box, or even if you have any comments about what Joe discussed today, feel free to go ahead and share your thoughts with us. I'd like to remind everyone that I have this webinar recorded, so once it is available, we will go ahead and notify everyone who is registered that a recording is available, and it will be added to the existing series recordings, and I went ahead and I provided a link to that series in the chat box, so you can go ahead and refer back to it, and that's where that recording will be housed once it's available. Okay, so while we wait for any questions that might come up, we did have a few questions that came up before today's session, so I will go ahead and pose those questions here to Joe. We will be sending out a link to the slides as well. I see that that question is coming in. So those slides will be added to the existing series recordings page, and it will also be sent out at that point in time. Okay, so Joe, let's go ahead and address the questions that came in before the webinar. So what are the two most important issues in laboratory systems?
From my perspective, it's education and planning. We've either moved past the phase of buying systems to solve individual problems or soon do that. Labs waste a lot of time moving data information between systems manually. That ties up people, and it means that the lab will never move beyond a certain plateau in productivity. Lab personnel need to understand what technologies are available to them, how they can be integrated into their workflows, and how they connect to other systems. And that's the education part. Planning takes that understanding and how things are going to work in both the short term and long term, plus the ability to deal with change, both technologically and handling change management for people as well.
Okay, great. Thank you for answering that question that came in. Again, I'm not seeing any more questions in the chat box, but I do have two more that came in before the webinar. Another question that came in asks, why can't we just use our IT people to troubleshoot our systems?
Well, they can if the problem can be easily isolated to a computer system or application. But getting to that point's the problem. I've dealt with cases where the symptom of a problem was simply a lot of noise in the instrument signal. The evidence for the problem was a chromatographic report that had way too many peaks in it. It wasn't a software problem, but rather a loose ground wire connecting to the outlet. The problem is going from the symptom to the solution and that to what the real problem is, and that requires understanding the process, the equipment, what contributing issues there are, and the trial and error of problem solving. Frequently you find that either IT people will go, well, let's see, we can understand the hardware, we can understand the software, but there's other stuff out there and we have no clues what that is. And sometimes instrument vendors will be very good at managing their instruments, but when it comes to the computer systems, they're not on top of all that stuff.
Okay, thank you for addressing that as well. The last question that came in asks, what are the issues with getting management to support a lab automation engineering position?
Probably the biggest one is having them understand the value of a specialized role. The position represents cost, and they need to see the potential return. A lot of that can come from avoiding bad purchases, faster problem resolution, which means less downtime in the lab, having access to people who can be effective at planning and implementing systems uh, that will work, really work, and be supportable. Doing that work means bridging the gap between IT and lab work, and that can be hard to define until a critical problem occurs. I've seen systems put in by people that have worked very well until the first upgrade is done, and then they crash and they don't work anymore because they weren't designed and built with the or engineered with the idea of upgrades being supported. So it's a matter of, gee, we don't know if we need them until you have a problem that can't be solved any other way.
Okay, thank you for addressing that as well, Joe. Oh, it does look like we are getting a comment here. Okay, so when an organization has many global labs, do you suggest a LAE in each location or a centralized team or a hybrid?
Well, I'm not sure what you mean by a hybrid, but I think each organization, each site is going to need its own personnel just to get a timely response. But I think what you need to do if you really have a global lab is have an organization put together where you have local support for the LAEs and then have them periodically get together so that people understand what's going on at different sites, where there might be common problems, common solutions to those problems, and so that coordination can get done properly. Having everybody operate independently uh, is a nice. It sometimes works a little bit, but as soon as you start dealing with coordination issues or people recognizing you have the same problems in multiple places that need to be solved, then the isolated issue becomes a problem. So it's a matter of having people on site so they can give a timely response to problems, but also have them coordinate with other people in different parts of the organization so that solutions can be passed around.
Okay, I hope that answers your question, Jameson. Okay, great. I think it did. It appears that we may be getting another question or maybe comment, so we'll take another second or here and just wait to see if something comes
Yeah.
through. Okay, there it is. What strategies can you suggest when corporate IT policies and decision making interfere with the operation of the lab? For example, non-standard operating systems or computers that prompts IT to boot off the network.
Yeah, that's pretty much the typical problem. Lab systems are diverse. They're not usually not Windows based or not always Windows based. You'll find Unix and other operating systems out there. The problem is to start at the the point of purchase. Make sure people understand what's going on. Make sure IT knows what you're purchasing and what the support strategies are. Uh, but the most important thing is keeping the lab's operations going. So as I pointed out a few slides ago, if the corporate policy is that everybody's operating system will be upgraded to the same level, and that upgrade causes the laboratory's computer to crash or the application not to work, then they've got to make a pretty quick decision on what their priorities are. And having everybody be at the same operating system level is not exactly a good priority. The main thing you got to do is to keep the labs running. And that happens frequently, particularly when you're dealing with small vendors. So the primary strategy is communications, letting people understand what the priorities are, what your support strategies are, making sure the vendors are going to be providing timely support as needed. And if an implementation or an upgrade has to be delayed, let people know soon enough so that they can incorporate that in their plans.
Got some great tips there. Scott, I hope that answers your question. We'll just wait another second here to see if anything else comes through. Okay, it looks like it does. Okay, as we wait for maybe those questions to come through, we do have a registration date set for the next webinar, of course. We will be sending that registration out once it is available. So if you are interested, stay tuned for that. I know that we'll be communicating more information about the next webinar in the LIMS Forum newsletter, as well as sending out a separate email to anyone who's attended here today, as well as maybe registered for maybe past series. So we will notify you in that way, or you'll see it in those newsletter communications. So you will see those shortly. I know a few people have commented that they're interested in attending the next session.
If
We
anyone
missed
has
any?
problems or has questions about support issues or needs help with support issues, and they don't want to address them now, my email address is on the slide, so you can contact me whenever it's convenient for you. Okay, so
I
there are
think
so
we
many
had that
small
question
vendors
from.
out there, yeah, that are not keeping up with updates and patching. That's a bit of a problem. Probably the simplest issue is as soon as data is generated by those systems, move it to another system where the data can be managed better. Um, there's a Small vendors are a bit of a problem. There was one I ran into at Pittsburgh conference a couple of years ago who was really excited about his instrument and the things it could do. And when I asked him about his software system, he said, "Well, we have software. It's there. We don't pay a lot of attention to it because we're primarily working on the instrument. And the software is the interface to the instrument. It's also where you get all your data. So it's basically, if they're having problems with your vendor, you're with the kind of issue that's on the screen, move your data from that system as soon as you can once it's processed, and that will help maintain the integrity of the data. But first, you have to make sure that all the results have been generated, that they've been checked and verified, and then move it off that system onto another one. Another issue along those lines is user communities. Find out how many other customers that vendor has, and put together a user group to help deal with the problem, or else pressure the vendor as a group to make sure things start getting done at a more timely basis.
Okay, great. I think that that is a good tip too and good idea. Yes, thank you. Okay, great. I think that answers their question there. Okay, well, I don't think there are any other questions coming through. We could probably go ahead and close out today's session. Like I said, this is being recorded, and we will send out a link to the recording once it's available. It will also be available on the LIMS forum, along with the other webinar recordings for this series. If you need to contact Joe with any additional questions, concerns, or topic ideas for future webinars, feel free to go ahead and email him. He's more than happy to go ahead and address those for you. Thank you, Joe, and everyone for attending today's webinar. And if you have any questions for me about today's webinar session, please let me know. Okay, thank you all for joining. Thank you so much, and thank you again, Joe.
You're welcome. Take it easy.